Hello class, it's Mr. Cablan here, and I'm going to start off the first lesson for the brand new chapter here for chapter 6, dealing with analyzing linear equations. And I mentioned in the previous chapter where we left off in the previous chapters. Actually, we're going to start in this particular chapter. So before we begin today's lesson, let's just do a quick review of where we ended in the last chapter here. So if you take a look at the screen I'm about to put up, this is the chart that or the screen that we ended off with in the last chapter when we were dealing with equations of lines. So just to do a quick recap, in the last chapter, we looked at two types of equations for direct variation and partial variation. Now, the majority of this course, this chapter here, will be focusing on this equation right here, the y equals mx plus b. And in this chapter, we'll be referring to this equation here as the equation of a line in slope and y-intercept form, specifically because we'll in every example where we're going to come up with the equation of a line, we'll need to calculate the slope first and then find what the y-intercept is, or where the line touches the y-axis. Now, today's lesson, we're going to go over the same things that we did in the last chapter. So some of the examples that we'll be seeing for today will sort of be like review from the previous chapters. So let's get right to it and see what that's all about here. So let's take a look at today's lesson here, dealing with equation of a line in slope y-intercept form. So when we're dealing with an equation in slope y-intercept form, okay, for the most part, we've seen two general directions of a line going up and a line going down. So anytime you see a line going up or going down, we're always going to start off with the equation of a line in the form of y equals mx plus b. And if you recall there, the m represents the slope and the b represents the y-intercept. And remember that the y-intercept is where the line touches the y-axis, which I've indicated there with a red dot. Now, in the last chapter, we also saw how we can calculate a horizontal line, and how we're going to approach a horizontal line in this lesson will be exactly the same as approaching a line that's going up or down. Now, you're going to see when we start looking at some examples here is that when you come up with a equation of a horizontal line, it's going to be y equals some number. Now, what we're going to see here is that when we're taking a look at a horizontal line, we just need to see where it touches the y-axis, and that will be the y-intercept. So the y-intercept of a horizontal line happens to be the equation of the horizontal line there. And remember that when we calculated the slope of all horizontal lines, no matter how long or how short, the slope of a horizontal line was always 0. Now, based on the two lines that you see on the screen here, horizontal lines and lines going up or down will always start off with y equals. The exception to that is when you see a vertical line. So you're going to see here with a vertical line, a line that goes from the top all the way to the bottom, where it touches the y-axis, or sorry, where it touches the x-axis is going to give us the equation of a vertical line. Now, also notice that when you're looking at the equation of a vertical line, okay, the equation of a vertical line is the only one that starts off with x equals. So that wherever the vertical line touches the x-axis, that will be the equation of a vertical line. And as you can see, I've designated that with a red dot there. And just a reminder that when you're looking at the slope of vertical line, all slopes of vertical lines, no matter how long or how short, will always be undefined. Okay, and just another reminder, as I said before, vertical lines are the only lines with an equation of x equals. So just keep that handy when we get to those examples. All right, let's see some examples dealing with the lines here. And let's start off with two lines that you're relatively familiar with. And we're going to start this off just with a basic calculation of rise over run. So remember that when we're looking at lines, always ask yourself which direction this line is going. So since this line here is going up from left to right, what we're going to have here is a positive slope. Now, since we're using rise over run, let's draw a right triangle underneath it, like so, and just count the number of spaces from the point to the end of the triangle there. So starting off with rise over here, starting from the top point, we're going to count two boxes over here. Okay, and the run here, just starting from the left side, we have 1, 2, and 3. So the run of the rise over run here is simply just going to be 2 over 3, and that's already going to be a fraction in lowest terms. And just as a reminder, when you get a fraction, just leave it as a fraction in lowest terms, and you're going to see that in one of the examples that we're going to see in this lesson. Now remember the y-intercept, we're just going to look at where this line touches the y-axis. And as we trace along this line, you're going to see that it's going to touch the y-axis here at -5. So from here, put it all together. This m of 2 over 3 is going to replace the m in the equation of y equals mx plus b. And this -5 here is going to replace this b in the equation as well. Now again, just to just remind ourselves for form here, when this -5 goes in for the b, okay, it's going to, we're going to put brackets around it. But don't forget that anytime you have two signs side by side, you always have to use the laws of integers in order for you to change it. So since we have a positive and a negative side by side, that will change itself to a negative. All right, this next one over here, as you can see, this is now a line that falls down to the right. So remember that any line that falls down from left to right is going to give us a negative slope. So for this one here, just a reminder, you always have to put the minus sign in front of the rise over run when you're doing the calculations here. So when we're doing the counting here, starting from the top left, so we have 1, 2, 3, 4. So we have a rise here of 4, okay, and a run here of 1 and 2. So notice that when I put this down for rise over run, I have -4 over 2, which reduces to a whole number of -2. All right, and last but not least here, we have the y-intercept here. As we take a look at this line, notice it touches the y-axis here at 3. So the equation of this line over here will be y will be y equals, and then remember the slope of -2 replaces the m, and the b of 3 replaces this b over here. Now it does help to highlight or just do something with the letters that you're replacing, just as a reminder where these numbers will be going. So the equation of that line will be y equals -2x plus 3. All right, so this is just a quick recap of how to use rise over run for lines going up and down. So now let's take a look at the two special cases here, specifically horizontal lines and vertical lines. So remember that when we're looking at horizontal lines or lines going from left to right, okay, we saw this in the last chapter that when we did the rise over run, it doesn't matter how long or how short a horizontal line is, the slope is always going to be 0. Okay, so that part will always be the same for all horizontal lines. Now, taking a look at the y-intercept, you can see that this line touches the y-axis at 4. So now what we're going to do here is we're going to use the equation y equals mx plus b, but we're going to discover something when we do this. So you're going to see when I take this 0 and replace it in for the m, and take this b and replace it for the 4, we're going to get y equals 0x plus 4. Now, remember that when you multiply 0 to any number or letter, it's just going to give us 0. So the equation of this horizontal line here will be y equals 4. Now, a little bit of a shortcut, and by all means, this is probably the best way to do it, is that anytime you see a horizontal line, it's always going to be y equals some number, where that some number is where it touches the y-axis, okay? So just remember that. So all these steps that we did before, I just did it just to show you how we get that. But ultimately, again, when you're looking at the equations of all horizontal lines, it's always going to be y equals. All right, you might want to just make put a star beside this one, because again, this one here again is a very, very special case, because remember that vertical lines, there was something special about the equations of all vertical lines. Now remember that when we're looking at vertical lines, we saw in the previous chapter that when we did rise over run, we wound up getting an error in our calculator. And I told you that when you have a vertical line, all vertical lines have a slope which was undefined, because we couldn't divide a number by 0 there. All right. Now, when you're looking at the y-intercept, okay, you're probably scratching your head when you're thinking, well, hey, is this a trick question? Well, if you really think about it, when you're looking at a vertical line, notice it is no, it's far away from the y-axis. Okay, in fact, okay, this is what's called something that's parallel to the y-axis, because as you can see, it's not going to touch the y-axis at any point. So guess what? The y-intercept for this is going to be none. Okay. Now again, the y-intercept is none because it will never, never, never touch the y-axis. Now, as I said before, when we're looking at vertical lines was the oddball of all of them, because remember that the uh, vertical lines were the ones with the equations that start off with x equals. So we have to remember that when we're coming up with the equation for this. Now remember that if you to come up with the equation of a vertical line, you just need to see where it touches the x-axis, which in this case here is going to be 2. Okay, so the equation of this vertical line is going to be x is equal to 2. Now again, since this is the exception to the other equations over here, okay, just make a note of that. Like I said, put a star beside it. I just have the pointing finger just as a reminder that it's an equation that starts off with x equals. All right, so that's how, again, these two examples here are just are the new examples dealing with equations of the two special cases. So I just want you to see that for horizontal lines, it's going to be y equals y equals where it touches the y-axis. So it's always just going to be the number. Okay, and the vertical lines, it's the only one where you have an equation that starts off with x equals. All right, let's move along here. And for the next one over here, we're actually going to revisit a technique that you also saw in the previous chapter when you're plotting a second point using a slope. Now, for this one over here, what we're going to do is that we're going to plot 2 points using only 2 pieces of information, the slope and the y-intercept. Now, what's important for this one over here are actually the sequence of steps based on the information that is provided for you. So let's follow the steps step by step here. So starting with the first step here, what we want to do here is to plot the y-intercept. So remember that the m represents the slope and b represents the y-intercept. So starting from the center here, my y-intercept here is going to be -1. So that's represented by that red dot. Now, it's the next step that's going to be very, very important because not only do you need to know how to use the slope to plot the second point, but you need to also know where you're going to start. So for step number 2, it says from the y-intercept, use the slope to plot the second point. And the way we're going to do this is we're going to use a slope of 2/3. Now, before we draw this line, let's think about what this line will look like. Well, since it's a positive slope, okay, what we're going to have here is a line that's going up and to the right. Now, the question is, well, by how many are we going to go up and how many are we going to go right? Now, remember that when you're given a slope, okay, what you have here are 2 numbers, a rise and a run, where the top number represents the rise and the bottom number represents the run. So since we have a rise of 2 here, okay, this is telling us that from the y-intercept, okay, we're going to go up 2. Okay, and then from there, the bottom number, which is the run, is going to tell us that we're going to go right 3. Now, I want you just to follow along because I am going to use guidelines first, and I'll tell you exactly what to draw in. So from the y-intercept, which we've already plotted, we're going to go up 2, okay, and right 3. Okay, and once we have that, these red lines again are just guides. We can now plot our point right there. All right, and we can draw a straight line straight through it, and that's pretty much it. Okay, so again, what we did here is from the y-intercept. Okay, we use the slope to plot the second point. And again, what we're going to do here, you always use the top number as a rise, which tells us which direction to go up. Okay, and the run here tells us which direction to go right. So the equation of this line in the form of y equals mx plus b will be y/2/3x, okay, plus -1. And don't forget, when you have a positive and negative together, change that to a minus sign. So that will be the equation of that line. And also get in the habit of labeling the lines after you draw them, because you're going to see this in the very final lesson that when you draw 2 lines, that's going to become very useful to identifying which line is which. All right, so let's take a look at another example. Now this time, notice that what we have here is a slope of -4 and a y-intercept of 5. Okay, so pay very close attention to how we do this one. Okay, so again, following the steps here, we're going to plot the y-intercept here of 5 first. So we're going to go up 5 from 0. Now you're going to see with this slope over here, notice what we have here is a whole number. So what we need to do with that whole number is to express it as a fraction. Now remember a couple of chapters ago, anytime you see a whole number, okay, there's an invisible 1 hidden underneath it like that. Now what's important for this one here is that since this is a negative slope, we know that this line will be falling down to the right. So also notice that I've put the negative here on top because that's going to help us draw the second point using the rise here. Now this one over here, we have a rise here of -4. Now if you think of a negative rise, which direction is that really going? Well, remember that when you have a negative rise, what's happening here is that the line will be going down. Specifically in this case here, it's going to be going down 4 units from the y-intercept that we've plotted. Now, again, just as a reminder, when you're looking at the negative, you're only going to apply it to the top number here. All right, and the bottom number will be the run, which is telling us to go right 1. So using the guidelines from the y-intercept, I'm going to go down 4, okay, and then right 1, and then plot. And as you can see, we now have a line that's falling down to the right. And just to finish off the equation, again, we're just going to replace the m here with a negative 4 and the b here with a 5. So the equation for this line will be y equals negative 4x plus 5. Okay, so again, just be careful with this one here. Anytime you see a whole number, doesn't matter if it's positive or negative. When you get a whole number, there's always going to be an invisible 1 underneath it. Again, when you're plotting points using the slope, you must do that step there because you do need a rise and a run to plot a second point. All right, so let's take a look at this one over here. Again, we're going to approach it the exact same way. We have a slope of 3 over 4, okay, and a y-intercept of 0. Okay, so for this one over here, we're going to first plot the y-intercept of 0, which is in the dead center. Now remember that what we have here is a slope of 3 over 4, which is a positive slope, so we should get a line that's going up and to the right. So remember that from here, this is a rise of 3. So from the y-intercept, we're going to go up 3. And then after we go up 3, this 4 tells us to go right 4. Okay, so from this y-intercept, we're going to go up 3 and then right 4 and plot. And as you can see, we get exactly what we want here. All right, for the equation of a line over here, the reason why I did this example is because I want you to see that when you have an equation of a line that's going to look like what we're about to see, okay, this is how you would approach the, drawing this type of equation. So what we have here, we're going to replace the 3 over 4 in for the m and the b for the 0. But quite often, especially in your textbooks as well as in many lessons here, you're going to see that when you have an equation that has a y-intercept of 0, it's actually going to be written without it. Okay, so that's why if you ever get an equation of where you just have the slope and the x and no number, okay, what you have there is a y-intercept of 0. And if you recall, this is an example of what was called direct variation, which we spent a lot of time with in the previous chapter. All right, so that's the reason why I did this particular example. All right, let's do another one here. So for this one here, we have a slope of 0 and a y-intercept of negative 6. So let's start off by plotting the y-intercept first of negative 6. Now, before we talk about how to draw the second point, we have to discuss something about the slope here. So remember when we have a slope of 0, okay, ask yourself, what type of line do we really have? Now, if you guessed horizontal or a line that's going straight from left to right, okay, then you're absolutely right. So since we've determined that the slope of 0 will give us a horizontal line, okay, we don't need another point. All we just need to do with the y-intercept is to draw a straight line straight through it like this. And that's pretty much it. So for the equation of that line, again, we're going to approach it the exact same way. Okay, so we're going to replace the 0 in for the x and the y-intercept of negative 6 in for the b. Okay, and remember when you multiply 0 to any number or letter, it's always going to give you 0. And since we have a positive and a negative together, we're just going to get a negative. So the equation of this horizontal line is just going to be y equals negative 6. And just as a reminder, all horizontal lines will always have y equals a number as the equation. Okay, and that number again is the y-intercept of where this horizontal line touches the y-axis. All right, so we've looked at the basic ways to graph lines using the slope and the y-intercept here. So let's now take a look at a word problem where we actually had to understand what the slope represents. So it says, for each graph, calculate the slope and interpret its meaning and use the slope and vertical intercept, which is the y-intercept, to determine the equation of a line. Now, if you take a look at the values for the horizontal axis, notice that these ones are going up by 1, which is fine. However, the lines for the numbers going up for the distance or vertical lines, notice each one here is going up by 100. So using rise over run probably isn't the wisest decision for this particular example. So the way we're going to calculate slope here, okay, is first label the points. Okay, and I've just picked these two because they're clearly defined. Okay, we're going to use our fancy formula of y2 minus y1 all over x2 minus x1 to solve for the slope of this line here. Now, before we put the numbers in, okay, just as a reminder, since this is a line that's going up to the right, our final answer for the slope, okay, should be positive, or should I say needs to be positive. Now, remember from the previous chapter when you're labeling points for using this formula, you always start off from the left, okay, and then go right. So remember that you always label the first point here as x1, y1, okay, and the second point is x2, y2. And again, just another friendly reminder, do not mix and match the letters and the numbers, okay? You label the first point as x1, y1, and the second point is x2, y2, okay? Don't change it. Now, once we've labeled it, we're going to carefully replace the numbers with the proper letters here. So y2 minus y1 will be 400 minus 100, and x2 minus x1 will be 4 minus 1. So let's simplify this further. So we have 400 minus 100, which is 300. Now, you notice I put in the units in this step here because what we want to do here is to represent slope and relate it back to rate of change. So when we divide these two numbers into each other, remember we must always have two units. So our final answer here will be 100 meters per second. Okay, so that will be the slope. Now the vertical intercept here, we just need to see where this line touches the y-axis. And as you can see here, it touches the y-axis at 0. Okay, so you can see here, this is an example of direct variation. So let's just finish this off with the equation here. So all I'm going to do here is replace the 100 for the m, okay, and the 0 with a b. So what we have here is an equation of y equals 100x plus 0, which you can also write down as y equals 100x. Now remember that if you have a 0 there, okay, proper mathematical convention, just write it down without the 0. Okay, and that's just a reminder again, this is just to relate it back to direct variation, is that when you have an equation in the form of y equals kx or y equals mx, it's always going to be direct variation. All right, the last example for this lesson here. Okay, again, what we have here is another line that's going up to the right. So what we want to do here is pick 2 points. So my first point will be 110 and then 214 because they're clearly defined. And what we have here is a line that's going up to the right, so we should have a positive slope here. Now remember that when you're labeling the points using the fancy formula, you just have to label the first point as x1, y1, and the second point is x2, y2. Okay, and then carefully put the numbers in. Now for the top, what we have here will be 14 minus 10, and the bottom would be 2 minus 1. Now in the next step, you're going to see I'm going to put in the units here. Okay, and for 4 over 1 over here, so we have 4 to be centimeters, and the time in below is weeks. Okay, that will give us a final answer here of 4 centimeters per week. Now you can see here the vertical intercept, we have to see where this line touches the vertical axis or the y-axis, which is actually an h over here. And as you can see, okay, it's going to touch the y-axis here at 6. So putting it into the equation of y equals mx plus b, we're going to replace the 4 in for the m, okay, and the 6 in for the b. So the equation of this line for this particular question here will be y equals 4x plus 6. All right, so that wraps up this particular lesson. Again, you can start working through the review by section over here, and I'll see you in the next lesson.